summarize them quickly. Here we go, infinity limits. You good? Okay, infinity limits. Okay, I just want to talk a little bit about what infinity is. Okay, my daughter says this all the time. She goes, Dad, I love you infinity times infinity times infinity. And my heart just swells 3 sizes when she says that to me. What does actual infinity mean though? Infinity is like the biggest number possible. So although my daughter tells me that she loves me infinity times infinity times infinity, she's lying to me. Okay, she really only loves me infinity because that's all you can love something. Okay? Now, so where this comes from here, okay? 3 over 0, and this is where the something over 0 thing. 3 over 0 does not equal infinity. 0 over 0 plus does equal infinity. 0 plus means infinity, 0 is the little end and 1 at the end. Okay, so it's like a very, very, very small number. This in fact equals infinity. This in fact equals negative infinity, that should say. And 3 can be any number. So using either powers of thing here. Let's say I add a number to infinity. Let's call it 25. Let's say my daughter says to me, Daddy, I love you infinity plus 1,000. What is infinity plus 1,000 really equal to? Just infinity still. There's no number bigger than infinity. What does infinity minus 8 million equal? Daddy, I really don't like you today. I only love you at infinity minus 8 million. What does that still equal? It's still infinity. Infinity is such a big number. Like when you add or subtract anything to it, there's no parallel to it. In the same way, what's 3 times infinity? We already said this one. Infinity. What's infinity divided by 25? Is infinity. Okay, you can't change these things. Okay? Now I want to get to all these rules of basic. Now I could use any number in there. I have to use numbers instead of variables. Okay, the concept is using things are too big. Here's the thing where things get tricky, and this is where people have problems with infinity. What's like 10 divided by infinity? Zero plus, but I'm going to call it 0 or 0 plus. Okay? If I have a number, any number, and I divide it by infinity. Now, here's the thing that gets the problems in. You want to see where your brain's going to explode today? Let's say you were to rearrange this equation. Doesn't this mean then that 10 equals 0 times infinity? 10 doesn't equal 0 times infinity. What's going on? Right? So just don't think that way, okay? It doesn't. Right? Infinity times 0 is actually still equal to 0, I think. I'm going to go with. Right? Because anything times, I'm going to go with that. I don't want to go. So where this is leading us into is infinity limits, okay? So you guys did this already without knowing it in advanced functions when you talked about end behavior of graphs around asymptotes. Does that sound familiar to anybody? Right? So I'm just going to do a few of these on the board to make sure they sound good, and then I'm going to call it a day here. And I'm going to let's see what somebody's going to say. Good. Okay, so example 2. Please put a star beside this one because the only one of these on your test, and I think there's a few on your side. Okay. So when I sub in infinity, what do I get as an answer? We're going for limits, always trying to evaluate. 3 times infinity is, infinity plus infinity is, infinity minus 1 is, so we're still at infinity in the numerator. This is going to be infinity over infinity, which is a problem. Now, here's the thing. Can somebody give me some suggestion on how I can solve this from advanced functions? Because we're going to use the same idea. How did you do this to find the end behavior when you had to graph this in advanced functions? I don't remember. So I know at least one person in this class knows. See, and I studied this. Yes?
Don't you do like you kind of do like you factor it first, and then whatever you get for x is kind of like above that a little bit and below that a little bit, kind of like the plus and minus.
Sort of, but I'm going to say no. That's because these don't factor firstly. Whoa, excuse me. Okay, I'll take it through here. We're going to divide through by the highest power of x in the denominator. Is this coming back for some people now? Okay, so just like before, we want to get rid of the infinities. So if you divide everything by x squared in this case, we're not actually breaking any laws, right? You're just going to divide through. And we learned over here that something divided by infinity equals 0. So that's going to cancel everything we don't need. Okay? So I write this as limit x approaches infinity. 3 x squared divided by x squared minus x divided by x squared minus 1 over x squared all over 2x squared divided by x squared plus 3x over x squared plus 11 over x squared. Does this look familiar to anyone other than you? This does. This is coming back, yes? Okay, so this equals limit x approaches infinity. 3 minus 1 over x minus 1 over x squared all over 2 plus 3 over x plus 11 over x squared. Okay, when you sub back in infinity, what happens? Sorry, let me ask you, is this new to anybody?
Because we always just went straight, like if anything divided by like a degree higher than that would be just.
This is the reason why.
You just set it straight to 0.
And now I'm setting it straight to 0 right now. That's all I'm going to do.
Oh.
So now this equals 3 over 2. So now this equals 3 over 2. Right? Right, because we said that 1 over infinity is 0. Right? 1 over infinity squared is 0. 3 over infinity is 0. And 11 over infinity is 0. So it's just 3 over 2. Now, is it okay to have an answer infinity? Yes, it is. Okay, let's say, for instance, and I'm going to really stop after this one, I swear. I have an expression like for limit x approaches infinity, 4x squared minus 9 all over x plus 1. Okay? Why is this one going to have an answer infinity? Yeah.
Because bottom of the denominator doesn't have a square.
Yeah. Right. When I divide through here, this changes to 4x minus 9 over x all over 1 plus 1 over x, which equals limit x approaches 0, 4 times infinity minus 0 all over 1 plus 0 equals infinity. I guess I'll do that. Okay, so it is. So it's possible to have an answer for infinity. Okay, it's also possible to have an answer of 0 if the degree could be higher in the denominator.
So you want to get like 0, like 1 over x to something for infinity?
Yes, you could do that, yeah.
So basically, if x is higher than the x, so it's going to equal infinity.
All right, I had two awesome limits that would have taken you huge amounts of time. I'll do those tomorrow. How's that? I'll give you a little bit of time today to work on the rest of to start your assignment if you want. Tomorrow I'll do half the class again and give you the other half to work on your assignment. That sound good? Sounds fair? Okay. On Monday, however, though, there will be no assignment time on Monday. On Monday, what I will be doing is I'll be taking, Tuesday, rephrase. On Tuesday, I'll be taking these 3 test reviews. My test reviews go like this. I will give you guys questions to try as a class. You will be doing my questions. If you choose to work on your assignment, that means you choose to work something else out of the class. Okay, because it's disrespectful for you guys to be here and not listening to me and work on your assignment. Okay? And everyone here is 18. I will call your parents and tell them that's fine. If you offend me, okay, you do that. Okay, if you're not 18, you're 17, whatever. Okay. All right? Are we all agree with that? Yes, I hope so. Okay, because it is actually, Monday is actually a useful day for you guys. Okay. And I'm going to pause. You can start your assignment right now. And I'll, yes. No, it's just a review of what's going on.
Narrows is that.
Yes.